right, this continues section 6.6. This was the system that I had started in the last video, and I finished it here, and we just have to highlight the solution. So I have drawn in this boundary line, and I've done my checkpoints. Notice that when it was in slope-intercept form, we saw that it was greater than or equal to this, and so we were going to shade above, we believe. So a little checkpoint here. I didn't use the origin this time because I wasn't sure where the origin lies, because my graphs, as you can see, are not very nice and neat. Yours would be much neater if they're with pencil and paper on an actual graph paper. So I have the 0, 1 instead of 0, 0, and I put that in, and I saw that that was true. Then I did the checkpoint below as well over here. I used 0, negative 3, and I saw that that was false, so I see that what I've shaded in is correct. Now, because my lines are really wonky here, it's also really hard to tell where these things cross, which is something that I make my intermediate algebra students do and not my algebra students, but I make them find where these two boundary lines cross, which is just simply the solution to a system of equations, a system of linear equations, which are those boundary lines that form this system here, these system equations. And so I make my intermediate algebra students find that point, because that point is a really important point in solving application problems. It's called the or a lot of times called the break-even point. So here is our solution, now highlighted in pink as the region right between these two lines and right where they intersect being the end of those solutions. And these are both solid, so the boundary lines around those are solid lines as well. Okay, now why don't you guys go ahead and try this next one on your own, and I'm not going to go through the particulars on that one. I'll just show you the solution and then you can check it. So pause here, solve that one, and see if you're correct. All right, this one was somewhat of a special case here, so you may not have gotten this one, but let's go over it anyway. So basically what I've drawn is my first equation up here with the solution above it. Notice slope-intercept form, it says greater than, and I only did a checkpoint above. I'm going to let you start sliding when we do systems, only when you do systems though, for only checking the solutions checkpoint, or the checkpoint in the solution to the system. And then here the equation, the second equation, and I shade below it, right? In slope-intercept form it says less than that, so I believe my checkpoint to be below it, and sure enough, that's the true statement. Now I've shaded both of these. Now what you notice is that there doesn't appear to be any overlap. And I'm not missing anything that there's no overlap, because I also know that these two lines are parallel. Remember, I can tell parallel lines because I have the same slope and different y-intercepts. And therefore, I know that these lines will never touch, never cross, and therefore there is not going to be any overlap, and therefore I am going to have a null set. All right, now moving along to the last type of equations, where we have the boundary lines being a vertical or a horizontal line. And I'm going to go ahead and let you do this one on your own and see if you get the solutions for those. So why don't you just go ahead and grab these two sets of systems and solve them on your own, and I'll make a short video after this one to show you the solutions of each of them. And I won't be going over the individual parts very distinctly. I'll just be generally showing you the two boundary lines and the overlap then created by those. So I will see you in the next video to check your work only.